In this video, we're going to talk about the last application of the integral in this class, which is called average value of a function. There is a way to compute it via the integral. So far, the way we've talked about the average value in this class, like for example, average cost, you can take the total function, let's say total cost, and divide it by x, the number of items, and you'll get the average cost. And that's how in general you can find the average, even in statistics. You can, for example, find the average score on your exams. You can add all the 4 exams, find the total, and divide it by 4. Well, you can actually do that with a continuous function as well on the interval from a to b. If you would like to find the average value of a function, let me show you what it looks like. Here's a function. And notice how this line represents the average going through this function. Again, it's just the average y value. So this is how we can do this. We can take the integral as the area under the curve, but then if we divide it by the length of the interval, do not forget to do this. If we divide by b minus a, then typically the average in this section is 1 over b minus a. We can pull it on the front since it's a constant, times the integral from a to b of f of x dx. So if we're trying to find the average of a function, let's say if f of x is x cubed and it's from -1 to 1. So how do we set this up? Average value of a function is 1 over 1 minus -1. These are the endpoints of the interval, times the integral from -1 to 1 of x cubed dx, which basically becomes 1/2 of the integral. And then we can evaluate it. So it would be 1/2 times the antiderivative of x cubed, which is x to the 4 over 4, from -1 to 1, which you can multiply. It becomes x to the 4 over 8 from -1 to 1. And we can plug in 1, the top value first, minus the lower value, -1 to the 4th. Now, since they're both the same, because -1 to the 4th is +1, we actually get 0, which could be an average value. If you draw this out from -1 to 1, it would be a symmetric function, and which is why it's 0, because -1 cubed is -1, +1 cubed is +1, so the average value is 0. So it should make sense why that is. And I think on the homework, you will have to select the correct graph as well. What if we have a different function, x cubed minus x, from 0 to 2? And again, it's a very similar idea. So average value would be 1 over 2 minus 0, which is 1 over 2, times integral from 0 to 2 of the function. And so I kept the constant on the outside, and the antiderivative becomes x to the 4 over 4 minus x squared over 2. And I just plugged in the 2 because 0 would just give us 0. And if I plug in the 2, so we'll get 2 to the 4, which is 16, over 4, that's 4. And then minus 2 squared, that's 4 over 2, that's 2. So 4 minus 2 is 2 times 1/2, so we get 1. So in here, average value is 1. And we can also do this with exponential functions. Let's say if it's e to the x from -1 to 1. Again, it's 1 over 2. The length of the interval is 2, times the integral from -1 to 1 e to the x dx. It becomes 1/2 e to the x. Basically, the antiderivative is the same from -1 to 1. And again, we plug in the top value 1 first, minus e to the -1. And I just plugged this in the calculator, and I got about 1.18 as the average value. And what are some applications? So let's say the cost in millions of dollars of a 30-second Super Bowl commercial in the years from 1980 to 2000 can be approximated by C of t equals to 0.044t plus $0.222 million. So we're given a cost function. But again, instead of number of items, it's actually in terms of the continuous time interval. So we cannot just divide it by time. We have to do this as a continuous function. But it's from 0 to 20. And the question is, what was the average cost of a Super Bowl commercial within the given period? So you may guess, we can set this up as 1 over 20, that's the length of the interval, times the integral from 0 to 20 of the function, times dt. And how I get the antiderivative, again, I keep the constant, and 0.044t squared over 2 becomes 0.022t squared. And then it becomes, I think this is a typo, it should actually be a plus right here, if I could draw this. 0.22t from 0 to 20. And we can plug in 20. You may want to double check the final answer. We can probably do this in class, but if you plug in 20, hopefully you get that as the answer. Maybe it was just a typo, but we can double check. And here is one more problem. Facebook membership, the number of new members joining Facebook each year from this period. So here we're given the rate once again. So you either can be given an amount or the rate. So it's from 2005 to middle of 2008. So if you note, the interval is actually from 0 to 3.5, and t is the number of years since the start of 2005. What was the average number of new members joining the Facebook each year? So we actually can find average rate as well. So that's the kind of the benefit of this method. So you can find average amount or average rate. So again, set this up as the integral 1 over and it should be 3.5, I believe. Oh no, what was the average from the start of 2005 to the start of 2008? Pardon my confusion, but it's only from 0 to 3, not the whole interval. So then it's correct, the setup. Then we have 1/3 times 12t cubed over 3, which becomes 4t cubed, minus 20t squared over 2, which is minus 10t squared, and then plus 10 becomes 10t from 0 to 3. And again, you can plug in 3 and evaluate it, and I get about 16 million members per year. And that's it. That's it for this video and for this course.